can you zoom in? So what happened is the chain got loose. I need to print something to keep the chain from going outside of the sprocket. As you can see, when you throttle the bike, it does move. And it has quite a bit of power. It was very... I tried to stop it and it was extremely difficult. As you can see, when I throttle the bike, the motor moves, then the pulley moves, that chain moves, and the bike moves as well. So the last 2 years I've been working on a 3D printed electric bike. About 2 years ago I was biking to school, but it was very problematic because I would leave early morning, I was tired, I didn't really want to bike, and I would also arrive to school sweaty and tired, and just, it wasn't a great experience. So I also noticed that the people with electric bikes were just like zooming past me on the trail, and I was just so jealous. So I went and I looked up electric bike prices, and I was trying to buy one, and they were like $500 or $600 minimum, which I was not going to pay $500 to $600 for an e-bike, especially because I had an idea. I thought I could use that old power drill I had at home and my 3D printer right here to make an electric bike for a lot cheaper, because I already had a motor from that drill, I had batteries, and I also had every plastic part I would need. And I thought maybe I just need bearings and shafts and I can make an electric bike. I thought bearings and shafts would only cost me 20 bucks, which was way cheaper than buying a $500 bike. So I set out on my plan, and I started using CAD and designing an electric bike. I thought the whole project would take me about a month, but it ended up taking a lot longer. I've been working on this project for 2 years and I'm still not even done with it. But yeah, I hope you like this video. I'll show you where I am now with my electric bike, and I hope you like the video. As you can see, when you throttle the bike, it does move. And it has quite a bit of power. It was very... I tried to stop it and it was extremely difficult. As you can see, when I throttle the bike, the motor moves, then the pulley moves, that chain moves, and the bike moves as well. So this is currently my electric bike. This is version 3. I have a DC motor here. It's a 997 DC motor. It has around 2.6 Newton meters of torque. I then have a 3-to-1 pulley reduction here and a 4-to-1 reduction here, and then that all drives this sprocket, which is connected to a chain and another sprocket, and this gives a total gear reduction ratio of 60-to-1, so that 2.6 Newton meters from this motor will deliver about 150 here. And by the way, that 2.6 Newton meters is stall torque, so in order to stall this bike you need 150 Newton meters on the back wheel. So with all that torque and this motor, which is 48 volts, this bike should be able to go around 15 miles an hour, assuming you leave the bike on the gear ratio of 1 and 1. It's mounted to this piece of wood, which I've mounted to the bike through these 3D printed mounts. This one right here is mounted to the seat, this one right here is mounted to the water bottle holder, this mounted to the top tube, and this one to the seat tube. I've attached an aluminum pulley right here, which then is connected by a belt to this pulley, which is 3D printed and connected to a 10mm shaft through these flanged couplings, which use set screws. And I have a flanged coupling on each side of the pulley, and they hold the pulley with screws, and they're connected to the shaft with set screws. I also have some tension on the belt through this. This is just a screw with bearings on it to tension the belt. I have a very similar thing happening on the other side. I have an aluminum pulley to a 3D printed pulley, which gives a gear reduction ratio of, this gives a reduction of 4:1. So this is a 9-tooth sprocket here, which was originally for a motorbike, but I sanded it down to be thin enough for this chain right here. And then this sprocket is then connected by a chain to this sprocket, which gives a reduction of 5:1. If you leave this bike on the lowest possible ratio, you'll get about 150 Newton meters of stall torque and about 15 miles per hour of like top speed. Maybe it could hit 20 if you're going down a downhill. And of course, you can always assist the bike with these cranks. And if you're on the highest ratio, which would be 3:7 or 3:8 on this bike, then you'll get a top speed of around 30 to 40 miles per hour. These belts are HTD 5M 15 belts, so that means they have a 5mm pitch and they're 15 millimeters wide. So for electronics, I have these two 18-volt Makita batteries that I got from Power Drills, and I have this 36-volt speed controller to control the motor, and I also have this throttle for the motor. So in the future, I want to put all these electronics on a rack that fits on the back wheel, but for now, just for testing, I'm going to put these electronics in a backpack. Kind of sketchy, but it works. There are some issues with this bike. I will say, I don't like the belt tension system. It's not, it works decently well, but I don't like how the screw is just sticking out so much. I feel like it might lead to some problems if you're going at a high speed. I will say, since this is a mid-drive e-bike and you're just supposed to have this sprocket supporting, you're just supposed to have the motor supporting you as you're biking, the motor actually goes too fast. It spins these cranks too fast for my feet to keep up, which is not very great. I think to solve this, I'll just have more gear reduction so I have more torque and less speed. Or I could just limit the voltage going to the motor. I also don't love this chain and how this is being used to drive the cranks of the bike. It's just, I don't know. I found it to be very annoying. I'm worried that my pants or something get caught in this chainring and then I strip my pants, because that's actually happened to me before. Not with this bike, but with another bike. So I probably need to 3D print some cover for this just to protect me. I also don't like how the pulleys are mounted. There's no bearing on this side of the pulley. I feel like it'll lead to some instability at a higher speed. The biggest issue with this bike, which I will hopefully fix in version 4, hopefully there's a video coming on that soon, is that if you try to push the pedals of this bike, it's extremely difficult. See, I'm pushing on the pedal, and it does go a little, but it's extremely difficult because of all this gear reduction. It makes it really difficult to drive the bike. It gives the motor a lot of power, but not me, the biker, when I push on the pedal. So I need to work on the gear reduction. The solution to this is to implement a clutch somewhere, so we can disengage the motor and this whole gear reduction, and that'll make it a lot easier to pedal. And that's actually what mid-drive e-bikes have, but I did not think of that, so I couldn't implement it. Hopefully I'll fix that on the next versions of this electric bike. Another thing I don't love about this solution to an e-bike is how much everything sticks out. So as you can see, when you're trying to pedal the bike and push these pedals, your leg will sometimes hit these pulleys on the side, or these, I can cut down the shafts, but I can't really do anything about how much these pulleys are sticking out. So I'm looking for a more integrated solution now, and that'll hopefully be version 4, and it'll be way better than this version. This is test number 1 of the e-bike. Can you zoom in? So what happened is the chain got loose. I need to print something to keep the chain from going outside of the sprocket. How does it? Well, that was unfortunate, but I want to say that wasn't a failure. It was a learning experience. Basically, the only thing I really need to do is make sure that this chain does not come off of this bracket, this sprocket. I think I just need to 3D print some sort of a cage to make sure that the chain does not come off the sprocket. But other than that, it was great. It had a lot of power. Okay, and I forgot to say thank you all for watching. If you made it this far into the video, that's amazing. I hope you enjoyed it, maybe learned something. I want to say that in the next video, I'll do a version 4 of the e-bike. Maybe show off, I'm definitely adding a clutch so that I can so I can engage and disengage the motor. That way I can actually pedal the pedals when the bike is not actually, when the motor is not engaged. Because right now it's very difficult to pedal the bikes because of all of that gear reduction. It makes it very difficult to actually pedal. Version 4 is going to be a lot better, so stay tuned for that. Hopefully that'll be just like a complete e-bike, and there's not much that really needs to be fixed after that. So yeah, thank you all for watching.